So, good morning, everybody. Yesterday, we had already seen about depolarization and repolarization. So, today we'll continue with leads, axis, and R wave progression. So, depolarization, there is electrical activation of the myocardium. Repolarization, there is electrical recovery of the myocardium. So, if the current flows towards the electrode, there is positive deflection. If it flows away from the electrode, there is downward deflection or negative deflection you can take up. The positive deflection is positive deflection. ECG records the electrical vectors and not the contraction itself. So it is only records the electrical activity of the heart. You are recording only the electrical activity of the heart. So it is a viewpoint. You see the heart in different views. So that is the whole point of doing an ECG. Same how you see a car in different views, like front, back, top, and sides. How does it look? Similarly, the heart is looked at the frontal and the horizontal plane. So one heart, several leads, same vector. That is the same electrical activity is measured in different, what do you say, different leads. And the vector can be positive in one lead, negative in another, or nearly isoelectric in another also. Einthoven's triangle, this slide is very important. You need to understand Einthoven's triangle and also draw this diagram and mug it up. That's the best thing. So you have three leads, 300 bipolar leads. Each compares two electrodes. That is lead one, which is right hand and left hand, and lead two, it's right hand and left leg, and lead three is left hand and left leg. So you need to understand how the electricity moves in these vectors. So heart is generating the electricity. So you are seeing, is the electrical vector moving towards this leads positive pole or not? So that is what you need to understand. So why do we need another three leads? That is AVR, AVL, and AVF. These are three extra frontal viewpoints which fills the gap between the lead 1, 2, 3. So you have AVR which looks the heart from the right shoulder, and AVL from the left shoulder, and AVF from the foot or the inferior. Why is it called augmented? Because a unipolar lead cannot generate so much electricity, so it is augmented at least 50%. So that is why it's called an A is added. It is an augmented limb leads. So there are six limb leads, six viewing directions in the frontal plane. So this is an x-axial reference system. This also you need to understand. You don't have to memorize it, so more have to memorize it initially. Then you understand the directions first, and the degrees come later. So where exactly is the current flowing? That is what. But you need to see the QRS axis is simply the average direction of the ventricular depolarization in the frontal. So you know exactly how the current is flowing through the heart. So here you need to see AVL is minus 30, 1 is 0 degrees, 2 is 60 degrees, and AVF is 90, and lead 3 is 120, and AVR is minus 150. So you need to understand this and you can memorize it. So both Einthoven triangle and this x-axial reference system, there's no other way. Draw it and memorize it. What is the QRS axis? The normal ventricular depolarization usually travels downwards and leftwards because the LV dominates the network. Because the LV is a bigger contraction, it contributes to bigger LV contraction and cardiac output. So the electrical activity flows towards the net vector flows towards the LV only. So what happens? Axis gives the direction and the leads gives the viewpoint, and polarity whether the vector approaches or leaves that positive pole. Whether it approaches or leads lead 1 and lead 2, where is it strongly positive, and AVR is usually negative because it moving right shoulder, it is moving away from the heart is here. So right shoulder is here. So vector is going downwards. So this here the current is measured will be always negative. AVR will always be negative in a normal ECG. If AVR is positive, then either there is an abnormal ECG. So you need to understand there is something wrong. So but lead 1 and lead 2 usually will be positive. So this is a very simple way. So just keep two thumbs. See if both are positive, that is AVF and lead 1 is enough. If both are positive, it's a normal lead. If AVF is positive and lead 1 is negative, then it is a rightward axis. Then if it's a leftward axis, when lead 1 is positive and AVF is negative, it's a leftward axis, and both are negative, then it is a extreme axis. So simple, both are positive normal leads, and if one is AV V1 is, so that is lead 1 is positive and AVF is leftward, and the other way around it is rightward, and both are negative, it is extreme axis. This is more than enough to understand the axis. So then you have the horizontal plane. You can see V1, V2, all these chest leads. See the heart in the horizontal plane. So same heart, but different, completely different sets of viewing angles. So you have V1, V2, which looks at the heart from the right and septal viewpoint, and V3, V4 looks at the anterior viewpoint, and V5, V6 looks at the lateral viewpoint. So this is the R wave progression vector story. So here we have V1 is usually, so as you know, it is traveling like this. The heart travels, the vector travels like this, the electricity travels like this towards the LVs here, the fifth intercostal space. So you know that downward and outward it travels. So you have the V1, V2, which has a deep S wave, and then V2, and then V3, V4, where the transition occurs, and then finally it becomes the positive R wave gets taller and S wave gets smaller. The major ventricular vector moves from right to left towards the LV. That's all you need to remember here. There's nothing much. You look at the heart on in the horizontal plane, and the limb leads look at the heart in the frontal. So these are the various ECG we know that the next we will discuss about it. And PQRST. Why was it named PQRST? Because all the other alphabets were taken. That's why they went to PQRST. Anyway, P is atrial depolarization, then PR interval, then QRS is ventricular depolarization. Then you have ST where the ventricles are uniformly depolarized. Then you have ventricular repolarization. I'm not going to go into details of the next one. Next, we'll discuss about T wave and other abnormalities tomorrow. Okay, thank you very much. We'll see you tomorrow. Bye bye.